Hello and welcome. So in this set of videos we're going to look at some problems that resemble the problems from problem set 4. Not exactly, but kind of we're looking at strategies that are useful for the problems in that set. So let's look at this first example. So we're basically looking at functions and graphical representation of functions as strategies for solving some applications. So in this example, you're driving 65 miles per hour from the Kansas state lines with a mile marker 0 to Salina, which is mile marker 130, along route I-35 or interstate I-35. Describe a linear function that calculates mile marker after t hours, and then describe another linear function that will calculate your distance from Salina after t hours. Okay, so let's look at a coordinate system here. Alright, so we're gonna draw some x and y axes. Alright, so we basically want to look, so we want a linear function that calculates miles after t hours. So we want our horizontal axis to be time, t in hours. That's a weird spelling of hours. Let's try again. And we want the y-axis to be distance, probably in miles. Okay, so let's see. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I think that's probably not a good scale. Alright, because we're going to, so you're driving 65 miles an hour and you're going 130 miles. That's only going to take 2 hours, right? So let's do 1, 2, 3, 4. Maybe let's do, this is 1 hour. 1, 2, 3, 4, 5. This is 2 hours. This is 3 hours. So let's have that scale. All right, and then we're going 130. We're going to mile marker 130. So distance-wise, 10, 20, 30, 40, 50, 60, 70, 80, 90. Let's make this every 20. So 20, 40, 60, 80, 100. 120, 140, 160, and so on. Okay, so each tick mark is 20 miles. All right, so if I'm looking at a function that calculates the mile marker after t hours, then we basically start here, because at t is 0, you're a mile marker 0. You're going 65 miles an hour, so at 1 hour, then you are at mile marker 65, so you've gone 65 miles, and after 2 hours you've gone 130 miles. Alright, so we are looking at this graph right here. Alright, now we can find a function for it. It's a linear function, so we have this constant rate of change. So the function that describes the distance, d with respect to t. The slope is the speed, the rate, 65 miles an hour, times the time, like speed times time, and the intercept, you're starting at 0, okay? So it's just going to be 65t. So the distance is 65t. All right, now let's look at the second part. Describe another linear function that will calculate your distance from Salina after t hours. All right, so Selena is, so for kind of this first function, the red one, this is mile marker 0. And by the time you reached here, it went to Selena. Right. But now we want to calculate the distance from Selena. That's let's call that S of t. All right, that's the distance from Selena. So initially, when you're at time 0, when you're a mile marker 0, you're 130 miles away from Selena. Okay. As you're driving, you're getting closer to Selena, so your distance from Selena is decreasing. By the time you reach 2 hours, which is 130 miles, then you're going to be at Selena. So the distance to Selena gets to 0. Right? So here we're going to go 65 miles an hour, but because the distance is decreasing, you're subtracting 65 miles each hour. So you're going to have negative 65t. And the starting point, the intercept, is going to be plus 130. Okay, so here with this linear function, at time 0, you're 130 miles away from Selena's. You are getting closer each hour. You're going to closer 65 miles, so the distance is shrinking. That's why the slope is negative. And then by the time you reach 2 hours, you're going to be there. Okay, so you can see that this distance, the two different kind of descriptions of the same scenario. So d of t calculates the distance from mile marker 0, and this one calculates the distance from Selena's, or Selena. Alright, cool. So this theme is going to be common in some of the problems in this problem set, looking at kind of the distance as it's kind of increasing away from something with positive slope, but also kind of turning it around and looking at the distance as decreasing as you're moving towards a location that you want to reach. All right, let's look at next example here. So a software company plans to bring a new product to market. The sales price per unit is $15, and the expense to produce and market X units is 100 times 1 plus square root of X. What is the profit potential? All right, so let's look at what's going on here. Okay, so there are two functions that we need to investigate. The first one has to do like with the sales price. So sales price per unit is $15. Okay, so through that information, we can figure out how much the company is bringing in. All right, so we can figure out the gross income. All right, let's call that G of X, gross income. Okay, so basically gross income means, you know, before you worry about what cost the company has, it's basically how much money, how much product are you selling? Okay, so it's like how much money are you getting in from selling the product? So if you have X equals the number of units, and the cost per unit is $15, right? So if you're selling one widget, then you're going to get $15. If you're selling 10 widgets, it's going to be 15 times 10, or 150. If you're selling 1,000,000 widgets, then it's going to be 15 times 1,000,000, which is 15 million, right? So 15 times X is going to be the gross income, right? Now the other function that you're interested is the cost, the expense. So the expense to produce, okay? So we can call that, let's call it expense, right? So it's the expense to produce and market. Okay, so that's the outgoings of the company. All right, so we're going to have another function u of x, which is 100 times 1 plus square root of x. All right, so we kind of have two different functions. This one brings money in. This one is going to be money out of the company for producing and marketing it. Okay? And you can see that from here, you can get a third function, which is the profit function. So you're going to have the profit, which is the gross income minus the expense will give you the profit function. So if you subtract these, if you have 15x minus 100 times 1 plus square root of x, that gives you the profit. Right? So let's graph these, the gross and the expense equation on the same graph, because these are simpler equations and we can sort of get information about the profit from there. The profit is a bit harder to graph because it's like you have a linear minus a square root. It's like, yeah, okay, what's going on? All right, so let's see. So the linear function, you can graph it by looking at the slope, or you can make a table of values. You can sort of pick some points. It's sort of different ways of graphing it. So we can, maybe we can pick some points. So we can have x, we have g of x here, which is equal to 15x. So if I'm selling 0, I'm going to get 0 money. If I'm selling 20 units, I'm going to get 15 times 20, which is 300. Okay, why am I not going x is 1, x is 2, x is 3? Does it really make sense? Like if you're a company that you're selling 1 or 2 things, you're not going to make any money. So, I mean, you could have things in hundreds or thousands here too, but it doesn't really make sense to go by ones. Okay, so let's go 40. 15 times 40 gives me 600. 60 times 15 gives me 900. Let's go 80 and 100. All right, 15 times 80, 1200. 15 times 100 is 1500. Okay, so let's also do the table for using the same x values. Let's do the table for expenses. Okay, so this is 100 and 1 plus square root of x. Okay, so x is 0 is going to be 100 times 1 plus square root of 0, which is 100. For 20, we have 100, 1 plus square root of 20. Plug that in the calculator. $547.2. Right? And I'm going to skip writing this step, but for 40, we're going to get 100, 1 plus square root of 40. 732.5. 100, 1 plus square root of 60. 874.6. 100, 1 plus square root of 80. 994.4. 100, 1 plus square root of 100. 1100. Okay. All right, so let's graph these. So we should set our axes. So let's go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. All right, so this is x. This is the number of items. All right, and then here I want to go to about 1500. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see, that's, let's say this is 500, 1,000, 1,500, and 2,000. Alright, cool. So the blue, so we have 0, 0. It's a straight line, 100 and 1,500. So I don't have to plot many points because I know it's a straight line. Let's see, 40 and 600. Oh no, that's 60 and 900. I'm trying to kind of graph good points here. There we go, something like this. All right, okay. So that's your gross income. All right, now let's do the green. Okay, so for x is 0, it's 100. So this one starts kind of here, a little bit up from the origin. For 20, it's 547. For 40, it's 732. What's that one? 750 over here. Just under there. For 60 is 874. So that's just under the curve. For 80, it's 994, just under 1,000. And for 100 is 1,100 over here. All right, so this one curves. It's a square root function which has sort of this typical kind of curving down feature, I guess. Okay, so this is the expenses. All right, cool. So we can see in the sort of the scale of the graph that we picked, they cross, which is significant. All right, if I was sort of picking these x values and my equations like were not crossing, that probably would not have been a good scale to pick for the x, because we do want to see the company eventually make a profit. Okay, so the profit is, as I said, you're subtracting. Okay, so at the beginning, the green curve is higher than the blue curve, so it has more expenses than the gross income. So up to here, the profit is negative. Okay, so up to here, there's like a net loss. Okay, which happens, with sort of, you're kind of ramping up. If you're not making enough of a product, your expenses are going to be less than the income that you generate. But from around here, the blue, sort of the income is bigger than the expenses. So this is when they're making profit. So the profit is sort of this amount of dollars, how much if I'm comparing like, for example, for 80 items, you can have 1,200 minus 994.4, that would give you the profit. Or for 100 items, 1,500 minus 1,100, it's $400 profit. Okay, so this is when you're having a net profit. Okay, so what businesses are interested in? It's what is the profit potential? Basically, this is when, this is kind of an analysis of the graph. So this point here is significant. In business, this is called the break-even point. All right, so for this part of the domain, x from 0 to that number, then it's a net loss. And then it reaches the break-even point when x is bigger than that number, then it's a net profit. Okay, so let's figure out the break-even point. All right, from the graph, you can see it's around 50, almost 60. If you compare like 60, yeah, at 60 you're making slightly more income than loss. So it's just below 60. To find it exactly, you want to set the equations equal to each other. So you're gonna set the 15x equals to 100 times 1 plus square root of x. You can plugging them in to see when they're equal. So 15x equals 100, 1 plus square root of x. All right, so let's do that. We have 15x equals 100 plus 100 square root of x. 15x minus 100 equals 100 square root of x. Let's divide everything by 100. You don't have to, but it makes it a little bit nicer. Okay, so 15 divided by 100 is 0.15. X minus 1 equals square root of x. Okay? Square root of equation, you want to square both sides to get rid of the square root. You got to FOIL this because it's two terms. So we have 0.15x squared minus 2 times 0.15x times 1 plus 1 squared equals x. So we have 0.15 squared gives me 0.0225x squared minus 0.3x plus 1 equals x. It's a quadratic, so subtract x from both sides. 0.0225x squared minus 1.3x plus 1 equals to 0. Alright. I'm going to divide everything by 0.0225. Again, not necessary, but I'm hoping the numbers are going to be a bit nicer to work with in the quadratic formula. We get x squared minus 1.3 divided by 0.0225 minus 57.78x plus 1 divided by 0.0225, 44.44. Arguably, I don't know if they're better. Alright, quadratic formula says negative b plus or minus b squared minus 4ac divided by 2a. So 57.78 plus or minus 57.78 squared minus 4 times 1 times 44.44 divided by 2. So 57.78 plus or minus, let's do that square root. 57.78 squared minus 4 times 44.44, lots of 4s. 56.22 divided by 2. All right, let's see what our two options are. So 57.78 plus 56.22 divided by 2. $57. There we go. We found our break-even point. Right? And the other option is going to be weird. Let's see. So we have 57.78 minus 56.22 divided by 2. Which is 0.78. Oh, actually, this is not dollars. This is how many items. Right. So if we look back at the graph, you can see that, so that 57 is right here. So this is like at 57 items. Okay. There's another crossing point here, I guess, when it's like 0.78 items. But that's sort of, it doesn't really make sense real life. The kind of mathematically the curve do cross there, but so like for making under one item, it's like there's a slight net profit, but then expenses go up again and then down. So this is kind of the real one at 57. So if up to 57 items, so when x is less than 57, it's a net loss. X equals 57 is the break-even point. and X is bigger than 57, the company is making a net profit. Okay, that's kind of the profit analysis that it was asking for. Oh, okay, so those are a couple of examples from this section that hopefully gives you some strategies for doing some problems. Again, they're not exactly the same. You're just kind of looking at sort of what kind of sort of graphical strategies and interpreting you're using for functions to answer some questions.